Hello student. Today topic of lecture, the endocrine glands. Next question, the anatomy of the adrenal glands, the endocrine organ of the pancreas, the anatomy of thyroid and parathyroid glands, the endocrine organ of the sex glands, the anatomy of the glandula pinealis, the anatomy of the hypophysis. As the result of metabolism taking place under the effect of nervous system, chemical compounds form in the body. Possessing high physiological activity, they regulate the normal performance of the function of the body and participate in process of its growth and development. This is chemical regulation. The endocrine glands have anatomo-physiological properties in common. They are devoid of ducts, since their secretion are discharged into the blood vascular system. The endocrine glands possess an expansively developed network of blood vessels. These blood vessels pierce the gland in different directions and play a role similar to that of ducts of the endocrine glands. The product of the secretory activity of the endocrine glands are known as hormones. Incretion. Embryologically, the endocrine differ in origin. 5 groups of endocrine glands. First group, endodermal glands arising from the pharynx and brachial pouches of the embryo form the brachydacinic group, the thyroid, parathyroid and thymus glands. Second group, endodermal glands of the intestinal tube, the islets of Langerhans in pancreas. Next, mesodermal glands, the cortex of the suprarenal and the sex glands. Next group, ectodermal glands originating from the encephalon form the neurogenic group, the epiphysis and hypophysis. Next group, ectodermal glands arising from the sympathetic elements form the group of adrenal system, the medulla and suprarenalis and chromophil bodies. This is pancreas, this is suprarenalis. This is thyroid, parathyroid, thymus, pancreas, suprarenal glands, epiphysis, hypophysis, and a sex gland, testes. This is 5 group of endocrine glands. Then adrenal glands, glandula suprarenalis. The adrenal gland is an endocrine organ of gold yellow color, which rests on the upper pole of the kidney within the retroperitoneal space. This is adrenal glands, kidney. Functions of the adrenal glands. The adrenal glands are an absolutely essential endocrine gland. The adrenal glands form hormones which are particularly necessary for managing stress and in emergency situations, and they have a regulating effect of metabolism and the circulation. Hormones of the cortex, steroid hormones, glucocorticoid, mineralocorticoids, androgens. Hormones of the medulla, catecholamines, adrenaline, noradrenaline. The adrenal glands, glandula suprarenalis, are 5 cm long and 2-3 cm wide, with a weight of 4 grams. Distinction is made between anterior and posterior and inferior surface. Fasces anterior, fasces inferior, and fasces posterior. Behind fasces posterior, as well as medial margo medialis, and superior body, margo superior, margo medialis. Surface, fasces anterior, fasces inferior, fasces posterior. At the medial border is the hilum, where the vascular, lymphatic and nervous system enter and exit artery, enter vein and lymphatic vessels. What do you see? This is glandula suprarenalis. The adrenal glands project onto the neck of the 11 and 12 ribs. What do you see? You see right suprarenal gland. This gives a kidney, right kidney. The adrenal glands project onto the neck of 11 and 12 ribs. The adrenal glands are located retroperitoneally. They lie directly below the diaphragm and in process rest upon the upper pole of the kidney and are embedded this common fat capsula adiposa, which are encased by the renal fasces renalis or fasces inferior, fasces renalis. Hereby they have the following topographical relationship. Fasces anterior, fasces visceralis of the liver and pars descendants of the duodenum, as well as vena cava inferior right. Posterior surface of the stomach left separated by the bursa ommentalis. Fasces posterior diaphragm, fasces renalis rest on the superior renal pole. Adrenal glands are derived from two embryonic sources, the ectodermal neural crest, which gives rise to the adrenal medulla, and the mesoderm, which gives rise to the adrenal cortex. Suprarenal glands have this is cortex and medulla. Cortex ectodermal neural crest and mesoderm medulla mesoderm. The adrenal glands are invested by their own collagenous capsule. It contains two parts, adrenal cortex and medulla. You see capsule. Adrenal glands are invested by their own collagenous capsule. Adrenal cortex contain parenchymal cells that synthesize and secrete but don't store various steroid hormones. The adrenal cortex is divided into three concentric histologically recognizable regions. Zone glomerulus, zona fasciculata, fasciculate, zone fasciculate, and zone reticularis, 3 zone, zone glomerulus, zone fasciculate, and zone reticularis, 3 zone capsule. There is connective tissue and adipose tissue. This is, you see, medulla at a border between cortex and medulla border. Cells of adrenal cortex synthesis hormones which performs next function, different function. Cells of, for example, cells of zone fasciculate regulators carbohydrate metabolism by promoting glucogenesis, promote breakdown of proteins, fat, anti-inflammatory properties, suppresses immune response, and other. The adrenal medulla is completely by the adrenal cortex. It contains 2 populations of parenchymal cells called chromaffin cells, which synthesize, store, and secrete the catecholamines. Catecholamines epinephrine and norepinephrine. What you see table with function: chromaffin cells, epinephrine hormones, fight or flight, freeze response, increase heart rate and force of contraction, relaxes bronchiolar smooth muscles, promote glycogenolysis and lipolysis. Norepinephrine increases cardiac output, rarely used clinically. Very important hormones for clinically. The pancreas, next endocrine glands. The pancreas is combined exocrine and endocrine gland of the digestive system and living people. The pancreas is secondary retroperitoneally in the central upper abdomen. The endocrine pancreas form different hormones and releases them into the blood through veins. The release of the blood sugar regulating hormones, insulin and glucagon, are controlled directly by the blood sugar level. This pancreas, this is tail, body, caput. What do you see? Pancreas. Pancreas. This is duodenum. This is caput, neck, body, tail. The eyelid of Langerhans eyelids of Langerhans are located in the tail. Of the body, tail of the pancreas. Eyelid of Langerhans is consisted two types cells and other. At A, synthesis the hormones are the acini, the achini of exocrine portion, and as the connective tissue septa in connective tissue septa is located vessels, blood vessels, lymphatic vessels, and nerves. What you see table, comparison of secretory cells in eyelid of Langerhans. This is next cell type, alpha, beta, delta, and other cell. Main cell, alpha, beta, because synthesis, glucagon, and insulin. Insulin decrease blood glucose levels, glucagon elevate blood glucose levels. These cells located in achini. In sweat. Then thyroid gland, glandula thyroidea, and parathyroid glands, glandula parathyroidea, are in the anterior throat area below the larynx. What you see? Glandula thyroidea, thyroid gland, located under the muscles, sternum, musculus sternum hyoideus, musculus, this is, you see, homohyoideus, os hyoideus. This is, you see, sternothyroideus, thyroideus. This is thyroid gland located under the muscles. On the surface the thyroid gland is large, H-shaped, unpacked gland. It consists of two lateral lobe, lobus sinister, lobus dexter, which are connected to each other by unpacked isthmus glandula thyroidea, glandula thyroidea lobus dexter, glandula thyroidea lobus sinister, isthmus glandula thyroidea. The lateral lobes surround the side surface of the trachea and are tightly attached to it by the connective tissue of the organ capsule. Thus the thyroid can follow the movement of the larynx and trachea during swallowing. The lateral lobes of the thyroid gland reach the groove between trachea and esophagus. Dorsomedially, where the nerve laryngeus recurrence causes. Dorsolaterally, the thyroid is adjacent to the carotid sheath. Carotid artery. This you see, trachea is the esophagus, dorsolaterally is located thyroid glands. It is a cross section through the neck at the level of thyroid gland. This is, you see, vertebra. This is thyroid gland. This posterior aspect. The parathyroid glands, this is 4 glands, are generally 4 lentisized individual organs, 2 superior and 2 inferior, located on the rear side of the thyroid gland. The weight of the glandula parathyroidea is approximately 40 milligram. This is thyroid. This is esophagus. This is trachea. This is artery. Arteria communis, caroticus communis, caroticus communis, subclavia, vena subclavia. This is arteria subclavia, arteria subclavia. Thyroid and parathyroid glands are part of the endocrine hormone-forming organs. The hormones produced here act on the complete metabolism and intervened to regulate the iodine and calcium balance of the body. The thyroid hormones T3 and trioxin T4 increase the basic metabolic rate and stimulate energy metabolism and growth and differentiation processes. The hormone produced by the parafollicular cell, C cells, and the thyroid calcitonin is the functional antagonist of the parad hormones, which is synthesized in the parathyroid glands. Calcitonin loves the blood calcium levels, where the antagonist parad hormones rise it. Parad hormone rise it. This is 3 hormone T3, T4 and calcitonin and parad hormone. The thyroid glands is surrounded by a dense, irregular collagenous connective tissue capsule, in which posteriorly our parathyroid glands are embedded. Septum from the capsule subdivided the thyroid glands into lobules containing follicles. This septum also serve as conduits for blood vessels, lymphatic vessels, and nerves. The thyroid follicles are spherical structure filled with colloid. Viscous gel, limicous gel, consisting mostly of iodinate seroglobulin. The follicular cells synthesis and release of the thyroid hormones through thyroxine T4 and triiodothyronina T3. The parafollicular cells are present singly on small clusters of cell between the follicular cells and basal lamina. They synthesis and release the calcitonin. Synthesis calcitonin. Parafollicular cells, follicular cells. The parathyroid gland, parenchyma, is composed of two types of the cell, chief cells and oxiphyll cells. Oxiphyll cells and chief cells. This is you see artery and vein artery. Chief cells synthesis and secrete parathyroid hormones. PTH acts of the osteoclast and also induces the decrease in calcium excretion by the ascending limb of Henry's loop of the kidney. PTH increases blood calcium by indirectly stimulating osteoclasts to reserve bone. Oxiphyll cells, the function of this cell is not known. Chief cells, synthesis and secrete parathyroid hormone, PTH. What you see? This is parathyroid gland. Next question, endocrine organ or the sex glands. It is the ovarium and testes. The ovarium, the production of the specific hormones in the ovary is associated with the secretion of the follicles themselves to this hormone called estrogen, synthesis estrogen, and second hormone luteum, the corpus luteum, synthesis and secrete progesterone. This is follicular cell synthesis estrogen and corpus luteum synthesis progesterone. Two hormones. The testis has polygonal interstitial cells located between seminiferous tubule are embedded in the testis in the connective tissue between the seminiferous tubules. This is interstitial gland of the internal secretion. They secrete the hormone testosterone and the androgen hormones. Testosterone, hormone testosterone. Next glands, glandula pinealis. Pinealis. The pineal body is situated on the dorsal side of third ventricle over the quadrigeminal plate, and is connected with thalamus by means of the habenuli. It's a small oval reddish body whose narrow end is directly downward and to the back. It measures 7 and 10 mm in length and 7 mm in height. This is very small. Its capsule is formed of pia mater, from which septum containing blood vessels and unmyelinate nerve fiber extend to subdivide into incomplete lobules. It's composed primarily of pinealocytes and neuroglial cells, interstitial cells. The pinealocytes synthesize and secrete melatonin, but almost only at night. The melatonin provides the fine toning for the day-night rhythm, induces deep sleep. This is pineal body, consists pinealocytes and neuroglial cells. We divide this connection tissue, septum. Pineal body, scheme. Pinealis gland or epiphysis. You see epiphysis. And habenuli, epiphysis, habenuli. Thalamus. And midbrain. This is brain stem posterior aspect. Next glands, hypophysis cerebri or glandula pituitaria. The hypophysis is a small spherical or oval gland, reddish in color, which connected with brain, with a tip, cinerum, and tube in infundibulum by means of hypophyseal stalk. The pituitary glands is located in fossa hypophysealis or sphenoidalis. You see fossa hypophysealis, you see sella turcica, and is separated by dira mater, diaphragma sella, from the actual central nervous system. This is turcica, sella turcica. This is hypophysis. This is infundibulum. This is tuber cinerum, infundibulum. What you see? Infundibulum. This is infundibulum. This is hypophysis. Hypophysis, sella turcica. This is infundibulum, midbrain, pons. This is epiphysis. This is thalamus. This is hypothalamus. Infundibulum, hypophysis. Epiphysis. The hypophysis is small, 18 mm in long. The hypophysis is divided into the adenohypophysis, and neurohypophysis. Two part. The adenohypophysis is divided into three parts: pars tuberalis, pars intermedia, pars distalis. It makes up the largest part of the anterior pituitary. Within it there are cells capable of the production and secretion of hormones. Pars intermedia. The pars intermedia consists of an irregular cell meant in humans is often only rudimentary. Pars tuberalis. The pars tuberalis wraps itself around the pituitary stem, tuber cinerum, and attachment itself to the hypothalamus. The chromophobic specific cells express melatonin receptor and produce subunit of thyrotropin. This is part tuberalis, pars intermedia, pars distalis. The cella turcica. The adenohypophysis affects the growth and development of the whole body. Somatotrophic hormone. In tumors of this lobe, intensified growth of the finger, nose and lip arches, acromegaly. The adenohypophysis also stimulates the activity of other endocrine glands, namely the thyrotrophic hormone and adrenal cortex, the adrenocorticotropic hormone and the sex glands follicular stimulating hormone FSGH, luteinizing hormone LH, and other hormones. The neurohypophysis is connected by the pituitary stem to the hypothalamus, which forms the floor of the third ventricle. In the transition area, the pituitary stem extends in funnel shape of the infundibulum. The neurohypophysis, adenohypophysis, infundibulum. The neurohypophysis augment the work of the smooth muscles of the vessels by raising blood pressure, vasopressin, and the muscles of the uterus, oxytocin. and also exerts an influence on the reabsorption of water in the kidney, the antidiuretic hormone. The neurohypophyses take part in neurosecretion, the production of specific neurosecretory substance by the hypothalamic neurons. Hemomediator. The hemomediator spread along the axons of these neurons through the hypophyseal stalk into neurohypophysis and pass there into the vessels through the vasoneural synapses. This is explained by the common origin of the hypothalamus and the hypophysis and the constructive connection through the hypophyseal stalk. The hypophysis is considered the center of the endocrine apparatus because it produces hormones which stimulate the development and function of other endocrine glands. You see table, the anterior pituitary adenohypophysis hormone. What you see? Hypophysis, neurohypophysis and adenohypophysis, and which synthesis many hormones. For example, pars distalis, cells of adenohypophysis synthesis next hormones, prolactin. This is acidophilic cells. Synthesis prolactin, which regulated mammary gland. For example, luteinizing hormone LH, regulation, ovulation, formation corpus lutein. Regulates function of the testes and the ovary. Next hormone, thyroid stimulating hormone. What you see, regulates thyroid gland. And other. This is a top table for you. You study this table at home. I finish this lecture. Thank you for attention. Goodbye, student.